Installing conduit containing branch circuit conductors through a wireway that houses unfused service conductors raises serious concerns about compliance with electrical codes and safe wiring practices. The primary issue revolves around the separation requirements for fused and unfused conductors. Wireways containing unfused service conductors, such as those entering from a meter box, are intended to carry only those conductors. These conductors are not protected by overcurrent devices at their source and thus present a higher risk of fault currents. Introducing additional circuits into this space, even if they are within a conduit, compromises the intended safety measures. The NEC, or National Electrical Code, provides specific guidelines regarding the installation and separation of different types of conductors to prevent hazards and ensure safety. Section 314.28 details requirements for junction boxes, pull boxes, and conduit bodies addressing conductor installation and access. While this section doesn't directly cover wireways, its principles of maintaining separation for safety are broadly applicable. Similarly, Article 366 covers auxiliary gutters, which are similar to wireways and used to supplement wiring spaces at meter centers, distribution centers, and similar points. The code emphasizes the need for proper conductor management and separation within these enclosures to prevent accidental contact or faults. The specific violation in the scenario described is the introduction of branch circuit conductors into a wireway designated for unfused service conductors. This is problematic for several reasons. Firstly, the unfused conductors are a potential source of high fault currents if a short circuit occurs before the main overcurrent protection device. Secondly, introducing additional conductors increases the risk of insulation damage and subsequent faults due to overcrowding and potential physical stress. Thirdly, the installation method using Carflex conduit passing through drilled holes in the wireway compromises the integrity and intended function of both the wireway and the conduit. The Carflex conduit itself may not be rated for direct contact with unfused conductors, and the drilled holes can create sharp edges that damage conductor insulation over time. To ensure compliance and safety, the following steps and consideration should be taken. 1. Remove the Carflex conduit and branch circuit conductors from the wireway. The wireway should only contain the unfused service entrance conductors. 2. Reroute the branch circuit conductors through a separate approved raceway system. This could involve installing a new conduit run that is entirely independent of the service entrance equipment. 3. Ensure that all wiring and raceway installations comply with the NEC and local electrical codes. This includes using the correct type and size of conduit, proper support and securement methods, and appropriate fittings and connectors. 4. Consider the ampacity of the conductors and the rating of the overcurrent protection devices. The conductor size must be adequate for the load it will carry, and the overcurrent protection must be sized to protect the conductor. NEC Table 310.16 provides ampacity ratings for various conductor types and sizes under different conditions. 5. Verify that all equipment is properly grounded and bonded. Branding ensures that fault currents can safely return to the source, minimizing the risk of electric shock. Bonding ensures that all metallic parts of the electrical system are at the same potential, reducing the likelihood of voltage differences that can cause shocks. 6. Consult with a qualified electrical inspector to review the installation and ensure compliance with all applicable codes and standards. An inspector can identify potential issues and provide guidance on how to correct them. Now, let's consider some alternative approaches to address the need for additional circuits in the vicinity of the service panel. Firstly, install a separate junction box or pull box. Instead of running conduit through the wireway, a separate enclosure can be installed adjacent to the service panel to serve as a transition point for the branch circuit conductors. This enclosure should be properly sized and rated for the application and must comply with NEC requirements for conductor fill and access. Secondly, use a larger service panel. If the existing service panel is undersized or lacks sufficient space for additional circuits, consider replacing it with a larger panel that has adequate capacity. This is often the most straightforward and code-compliant solution. Thirdly, install a subpanel. A subpanel can be installed downstream of the main service panel to provide additional circuit capacity. The subpanel must be properly sized and protected by an overcurrent device in the main panel. The feeder conductors supplying the subpanel must be sized according to their ampacity and protected by the appropriate overcurrent device. Fourthly, employ surface-mounted raceway. For situations where it is difficult to run conduit concealed within walls or ceilings, surface-mounted raceway systems can provide a flexible and aesthetically acceptable solution. These raceways are available in various sizes and materials and can be easily installed to route branch circuit conductors. Remember to select a raceway system that is appropriate for the environment and application. Fifthly, utilize existing conduit pathways if available. Before installing new conduit, evaluate whether there are any existing conduit pathways that can be utilized for the new branch circuits. This can minimize the amount of new conduit that needs to be installed and reduce disruption to the existing electrical system. However, ensure that the existing conduit is properly sized and rated for the additional conductors. In summary, running conduit with branch circuit conductors through a wireway containing unfused service conductors is generally not compliant with electrical codes and presents significant safety risks. The proper approach involves maintaining separation between fused and unfused conductors, using approved raceway systems, and complying with all applicable NEC requirements. Consulting with a qualified electrician and electrical inspector is crucial to ensure a safe and compliant installation. Always prioritize safety and adherence to code requirements when working with electrical systems. Understanding the principles behind these requirements is essential for preventing hazards and ensuring the long-term reliability of the electrical installation. The issue with running conduit through the wireway lies in the potential compromise of safety and code compliance. The wireway, designed to house unfused conductors, is a critical component of the service entrance. Unfused conductors, lacking upstream overcurrent protection, are particularly hazardous because a fault could result in extremely high currents. Introducing other conductors into this space, even within a conduit, elevates the risk of damage to insulation, short circuits, and potential fire hazards. The use of Carflex, a flexible conduit, introduces additional concerns. Carflex might not be rated for direct contact with unfused conductors or for the environmental conditions within the wireway. Also, drilling holes in the wireway can weaken its structure and create sharp edges that could damage the conduit and the conductors inside. NEC Section 314.28, although specifically addressing junction boxes, provides insight into conductor management and spacing. It emphasizes maintaining adequate space and protection to prevent damage to conductors. Article 366, concerning auxiliary gutters, offers further guidance on conductor management in enclosures supplementing wiring spaces at distribution centers. These guidelines reinforce the importance of separating different types of conductors to minimize risks. The code also addresses conductor ampacity, grounding, and bonding, all vital for electrical safety. Conductor ampacity, defined in NEC Table 310.16, ensures that conductors are sized adequately for the current they carry, preventing overheating. Grounding and bonding, essential for fault current paths, reduce the risk of electric shock. For a compliant and safe installation, the immediate action is to remove the Carflex conduit and branch circuit conductors from the wireway. Rerouting the branch circuits through a separate, approved raceway system is essential. This raceway should be independent of the service entrance equipment and comply fully with the NEC and local electrical codes, using the correct type and size of conduit, proper support, and appropriate fittings. An alternative solution is to install a separate junction box or pull box near the service panel for the branch circuit conductors. This enclosure must be properly sized, rated, and compliant with NEC requirements for conductor fill and accessibility. If the existing service panel is insufficient, consider upgrading to a larger panel with adequate capacity for additional circuits. Another option is to install a subpanel downstream of the main panel protected by an overcurrent device, with feeder conductors sized appropriately. Surface-mounted raceway systems offer a flexible solution for routing branch circuit conductors where concealed conduit is impractical. Select a system appropriate for the environment and application. Before adding new conduit, assess existing pathways that could be used for the new branch circuits, ensuring they are properly sized and rated. In conclusion, the installation violates the separation of fused and unfused conductors, posing significant safety risks. Compliance with the electrical codes, proper raceway systems, and consulting qualified professionals are paramount.